Hi everybody, in this demo here we're going to be going over the How Big Is Your Protist lab. We're going to do the first half on this video, and then we can do the second half, the microorganisms, on the next video. So when we're trying to measure something, it's pretty easy. Usually we just grab our ruler and we can figure out how big something, we can measure it, we can figure out how tall it is. But what do you do when you have a microorganism that's super small? I can't even see it like this, so let alone trying to use a ruler is not really going to work. But something I do have is I have my microscope, and I can use my microscope as a ruler. So to start with, I need a petri dish, I need a penny, and I need a paper clip, and the ruler is what I'll use. So just follow along on the worksheet, and I'll lead you through this. So what we're going to do is we're going to start with the petri dish and treat the petri dish as if this is the circle that I see when I look down a microscope. This is what I see. So what do I see? I see a circle. First thing I want to do is I want to come up with D, the diameter of the petri dish. So when I look down there, how big is it? D is diameter of the petri dish. And so I use the ruler and I measure how far it is across the center. And mine is 137.4 millimeters. Yours is going to be totally different than this because you guys are using either the bottom of the dish or using the top of the dish. But what I'm doing, I'm just making up numbers because I don't want to give you the answers. I want you guys to really do this on your own. So, D, diameter of dish. I measure it, millimeters, got it. Next thing, I want to do N. N is my estimated number. If I had microorganisms and I put them onto the petri dish, how many would it take to form a line across from one side to the other? So the penny is going to represent a microorganism. Now if I put the penny in the middle, I have to count so many microorganisms to the left, and then I get a fraction, and I count microorganisms to the right, and I got another fraction. Now I'm adding these two numbers together. So it's much easier if I start out by taking the penny and I slide it to one side. Then I can visualize if I had more microorganisms, how many would it take side by side to get from one side to the other? All right? So that way I only have a fraction on this side by starting at the side. So as I go across, I go 1, 2, 3, 4. I just use my mind's eye. I can't touch it as I'm going across because remember, I'd be as if I'm looking down a microscope and making an estimate. So I set it on the table, put the penny, and I just look at it. And I look down on it, and I use my mind's eye, and I come up with 1, 2, 3, 4, 5, 6, 6.4 pennies to get from one side to the other of the dish. Next step, and I write that on the worksheet. Remember to use your units, so I wrote down 6.4 pennies, and before that I put down millimeters after my answer, so showing work. D divided by N, that's math, that's a math formula, and so I'll go ahead and write that out. So I'll take my 137.4 millimeters, and I'm going to divide by my 6.4 pennies, and I'll write that out, get that set, showing the work, and I write that on the next line down from that. Next column, next line below that, it says actual diameter of pennies. How do I come up with the actual diameter of pennies? I have to actually measure it. So take my ruler, come up with it, and I get for my example, I get a 19.8 millimeters. Write that on my worksheet, and then my two numbers were close to each other. I had estimated my estimated number based on using my mind's eye. I thought that it was 21.5 millimeters, and really it turned out to be 19.8. So I have a little bit of error. I go ahead and I find out my percent error. So percent error is the actual minus the estimated divided by the actual times 100. 3 steps. Write out the formula, substitute in the numbers, and now I'm going to come up with a percent error at the end. So this is how I do the penny part. All right, for data table number 2, we're going to try something a little bit different. This time, we're going to use the paper clip. The paper clip is not round like the penny, so we have actually a length and a width that we have to deal with it. That's L and W on your worksheet. So to start with, I have D. D is still the same diameter that my dish was, so I just copy that out of data table 1, put it on a table 2. L and W, those are my guesses, my best guess using my scientific eye. So L is if I could imagine if I line my pennies up lengthwise, how many would it take? So I got to like imagine more paper clips. Imagine. I get across how many that is. And then W is the width. If I line them up this way, side by side, shoulder to shoulder, how many would it take to get across the screen? Then I go through and do estimated length and estimated width. So before it was D divided by N. This time it's going to be D divided by L for my estimated length, and it's going to be D divided by W for my estimated width on that. Show the 3 steps. Formula, substitute them with units, answer with units. Actual length and actual width. Actually have to measure them. Actually how long are they for the length, and actually how wide are they for the width on that. And then I'm going to come back with the percent error in the end. Same formula, actual minus the estimated divided by actual times 100 gives us a percent error. First time through, you may have pretty high percent errors. That's okay. We'll develop in the next lab. We'll start with the microorganisms, and we'll use this because remember when we look down the microscope, we see a circle and we see an object in our field of view, and we'll be able to calculate the size of the microorganisms that I give you on the slides. Good luck.